In section 8 of chapter 4, we're going to be doing literally the exact same thing we did in section 7. We're still going to be finding the axis symmetry, vertex, y-intercept, and the x-intercepts. There's only one difference. In the last lesson, all the quadratics I gave you were in standard form. ax squared plus bx plus c. In this lesson, they're going to be in what is called vertex form, or what you might be more familiar with, graphing form. So where you can figure out if it's going left or right, up or down, stretch, compress. It's in that formatting, but we're going to be doing this chapter's material on it. All right, let's hop into the problem. Now, believe it or not, at least in my opinion, this is a lot easier than the last lesson. The last lesson was a lot more computationally challenging, specifically because factoring was involved, or potentially the quadratic formula. This is a lot more straightforward. Now, if we harken back to that lesson when we were graphing a bunch of different parent functions, you might remember by looking at this that it is shifted right 1 and up 6. You go right 1 and up 6. That's where the vertex is. That's why this is called vertex form. So it actually tells you the vertex right off the get-go. The vertex is going to be right 1 up 6. Bam, we just got the vertex just by looking at it. Additionally, if you recall, the axis of symmetry has to go through the vertex, or a better way of saying it is the vertex has to be on the axis of symmetry. So we also know the axis of symmetry. It is the x value of the vertex. X equals 1. Before I go into y-intercept and x-intercepts, let's graph this information that I have. The x symmetry is at positive 1, so I go right 1 and draw a vertical dashed line. The vertex, which is either the bottom of a parabola facing upward or the top of a parabola facing downward, is going to be at 1, 6, right 1 up 6, which is right here. So now I already know 2 of the 4 pieces of information, although technically it's 5 because x-intercepts come in pairs, that I need to graph this. Next, the y-intercept. Now for the y-intercept and the x-intercept, we are going to have to do some calculations. Luckily, the calculations are relatively straightforward and simple. If you want to find the y-intercept, if you want to find where a graph hits on the y-axis, all y-intercepts have one thing in common, regardless if we're here, or here, or here, or here. All y-intercepts have an x value of 0. You haven't moved left or right, you're just going up and down. Therefore, if you want to find the y-intercept, you just set the x value equal to 0. So h of 0 would be equal to -2 times 0 minus 1 squared plus 6. That is equal to -2 times -1 quantity squared plus 6. That's equal to -2 times 1 plus 6. That's -2 plus 6. It's -4. This is my y-intercept.
Wait, isn't it 4?
Positive 4. Thank you. I swear I can math. 1, 2, 3, 4. There it is. Now, on your assignment, it asks for you to find the reflection of the y-intercept. I don't need that. All I need is the vertex, axis symmetry, y-intercept, and then the last thing I'm going to do, which is finding the x-intercepts. So for the x-intercepts, which are on the x-axis, it's the exact opposite of the y-intercepts. Now the y values are 0, so now I'm going to set h of x equal to 0. And I'm going to get 0 equals -2 times the quantity of x minus 1 quantity squared plus 6. And you've already worked with problems like this. When we were doing completing the square, we solved problems like this. If I want to solve for x, I'm going to subtract 6 from both sides. That'll leave me with -6 is equal to -2 times the quantity of x minus 1 quantity squared. Now I need to get rid of the -2 that's being multiplied. So I have to divide both sides by -2. And I will get +3 is equal to the quantity of x minus 1 quantity squared. Now I need to get rid of the square, so I'm going to square root both sides. Don't forget your plus or minus. These will eliminate. You might ask yourself, Mr. Silva, square root of 3 is not a perfect square. That's fine. We're just going to leave it as plus or minus the square root of 3. Is equal to x minus 1. We're going to add 1 to both sides. So the 1's eliminate. I'm going to write my work over here. That means x is equal to 1 plus or minus the square root of 3. Now this is a really good algebraic answer. However, seeing as how we're trying to graph, it might be beneficial for us to find the decimal equivalent so that we can graph this. So there are two answers here. The square root of 3 is roughly 1.7. So 1 plus 1.7 is 2.7. 1 minus 1.7 is negative 0.7, roughly. So if I go 2.7's right here, negative 0.7's right here, and now you can kind of see how these 4 dots that I have, the blue, the green, and the 2 purples, they kind of look like they're going to form a parabola, like they're going to form the shape of a U, because that's what they do. They form the shape of a U.